This is Nupul and Pradyumna. We present the application Cloudbook. The primary motivation for this application is we can offload searching high quantity address books to the cloud, something which currently doesn't happen today. Second, we also facilitate the creation of something we call a social business card, something that you can exchange details with others. Say you meet somebody and you hit off and you would like to be in touch. All you need to do is take your phone, punch in their number as you would still do today when you like to be in touch, and this time you click exchange. When you click exchange, the cloud swaps the business cards of the two users, and each one gets the contacts which they wish to expose straight into your address book. So all you do is enter a number and you get their entire contact details if they've given you the permissions to do so. We haven't modeled the permission system as yet, just to keep this as a proof of concept, but we've kept this relatively simple. We'll see the simulation in later slides. So how did we achieve what we did? Well, we created our Cloudbook as a RESTful service that would run off Windows Azure. We exposed our entire Cloudbook API as URLs with verbs like get, post, put, and delete, the primary for which we use for our system. And the data storage, that's your address book, was partitioned on the Windows Azure table such that there was one address book per user. So the Windows Azure table is more like this whole monolithic table, but on Azure it can split across machines. So we can actually have one address book per user just based on the username of the person. Just as a proof of concept, we even tested out by firing these queries of the iPhones and Android phones that we have, just to check if how the deployment is on the servers for portability reasons, and just to check whether we can work off any machine without any problems. So this was just one added feature. So this is a quick brief up of the technologies that we used. We deployed the system on Windows Azure. We used the Windows Azure tables, we used all the Windows technologies as well as the REST architectural style. But the primary component which is plugging things together is the WCF framework, which is known as the Windows Communication Framework, which is the underlying framework for exposing our entire service as REST and having it connected through the Windows Compact edition on the phone, and so on and so forth. So these are the challenges that we faced during the development of this project. The primary one, being the most disappointing one that we came to know very late, is WCF and Azure to give a REST service is a known bug that has yet to be fixed, in fact. And we've even raised a service ticket with Microsoft to get that out of the way. The entire project is a simulation running off the emulators. Of course, it comes with its own limitations. We tried actually running the service on a LAN, but Windows mobile phones are a nightmare to just get the Wi-Fi sustained over the whole period. In fact, we had no problems with Android or the iPhones just picking up the REST services from the local LAN, but the Windows phones took about 5 hours, and we kind of gave up and we completely shifted to a simulation approach. The other issue being that Visual Studio doesn't allow more than one instance of the emulator to run. So we had to use a couple of tricks here and there and some virtual machines DLLs by Microsoft itself. It's called the virtual PC, the VPC DLLs, which we had to kind of install and use that as a workaround just to get the thing working on one system in concurrence with the entire workflow. Just before we proceed to see the demo, we'll have a quick look at how it has been configured as a REST service. We'll enter the URL. We've loaded this service as by this URL on the local LAN, and this is what we get. Welcome to the Cloudbook service. We can also view, as we said, we have made it as a REST service, so we have the URL well architected and designed. So now here is the reference. If you go to Cloudbook and the address book of the user is simple, you just press enter and it shows you the XML, the data pertaining to that particular user that's here. If we wish to further see the user details of, say, this user, just take the ID, and it's again a simple get query that is just appending to the URL. social business card pertaining to the user. This is the main crux of the entire application. It was just a quick demo to show it in raw XML before we show it to you in the application. So we have some things in the cloud. We are just showing a preview here, and then we click fetch. We see one item with search. We click view contact details, and we get all his contact details which were there. So this is the way it works. Sweet. Click OK. And we can search by name if we wish to. Like I say fetch, we find out okay, we view his contact details, and I did not view any of that. I can actually even have something like that belongs to both the people, and I can choose to view that person's details. I do view contact and I see all his details. That's fine. And I click OK, and I so we enter the number of the person whose ID we wish to swap, 323. And we send a request for that ID, and we receive the username of this person who was there. To show that we have actually he has actually received, we will go and look in his address book, and you will find Paddy G, which was the username associated with this person, and you can view the contact details. And his Facebook was not configured, and he did not have any LinkedIn contacts. So we effectively have a successful swap, and for some reason, so we see that was the business card that was swapped. Here is the business card that was authentically created, and here we see the same Brady G which has here. We view the contact, and we have the same 213. This we have just not displayed the email ID, we just displayed a subset of details that we require. We can click OK on either of them, and so we click the record. We wish to just show that we can search the contacts effectively. So he has Nupol and Pradi. This is our own business card that is visible. We've just kept it for debugging purposes, but to show that we can actually search, if I actually type 308, I know that this number is only in one of these searches, and I click fetch, and it searches, and it effectively returns me the data. I can view the contact details and see what data that I can get for that person. Click OK. Okay, so effectively we've been able to exchange the business cards as well as configure each of the business cards by two different people on whatever that was there. So this is just to show that we actually have the data in the cloud. So this is the Azure Storage Explorer, a tool that helps us look at the Azure tables. And here we see that we have some I don't blogs and blogs, some random values that we entered. But our main notion is these were the 4 people that were actually there in each of the address books: Harpreet, Nupul, Akhil, and Freddy. And it's partitioned, so on the cloud this is effectively stored per user. So the partition key is the username, and that's what we have, the user ID in the business card. So this address book belongs to Nupul, and this belongs to Pradi, and we have all these people. We also currently just stored our own business card with ourselves, because that's how we are going to simulate the fact that we actually store the business card on the cloud. and these are the two things that effectively get swapped and get allocated into each other's account. So we are just showing a preview of how that is supposed to happen. Now if we run the query, we see this was what it was before running the query, and after the swap has actually happened, we see that Nupul has the account has increased by 3 and Pradi has increased by 1. So Pradi now has Nupul's account and Nupul now has Pradi's email ID on the cloud, which has also been pulled off on the system.